How's it going, Martin? It's really good to finally have you on the podcast here. I feel like we've been trying to schedule this thing for quite a long time, but having a new baby at home can really change things for you in
Yeah,
ways that are significant that you don't expect.
yeah, that's for sure. I've had a few, and they definitely throw curveballs for sure. But it's good to be here, and thanks for having me on and being patient with getting things scheduled.
Yeah, absolutely. Well, I appreciate your patience as well. Um, so talk to me a bit about how you got started going into cybersecurity or just IT overall, right? Like
Yeah.
what made you think that this area was a good idea, that this was something that you wanted to do? Did you see the opportunity, or was it like a comfortable transition potentially?
Well, that's a big story. Let's see. So to get into my background, getting into IT, we have to go all the way back to the 90s. I got my computer engineering degree from Clarkson University back in 92. And, I kind of went out and started working just as a software engineer for a while. And eventually I ended up moving to Maryland and getting a job with a defense contractor working on, information security is what we called it at the time. Cybersecurity is what we call it now. Back in the mid 90s, this is like 96 or so. If you wanted to learn cybersecurity, you had to teach yourself. There were no college courses. There was no, secondary learning, or very little out there to go pick it up. So, a lot of what you did was there were a few books out. Certainly, a lot of them talked about cryptography and things like that as a means to securing data. But if you want to learn about hacking and exploits and security tools, you basically had to read source code in a lot of cases. There were text files out there, and there was frac and stuff like that. Not the industry, the hacker zines. And basically, the way that I taught myself was working in my day job and also writing my own tools. Since I am a software guy, I started writing little scanners and firewalls and sniffers and things like that. And eventually, I decided it'd be a fun project to do would be to write my own cross-platform sniffer that came to be called Snort, and it turned into a lot more than that. But the whole career path of getting into and deciding that cybersecurity was the field that I wanted to go into was really back at the early days. So I was working as a government contractor for here in Central Maryland. That usually means one of the very few places that you're working for. And one day the customer came in. And it was a team from the shop that we were doing our contracting with to check over our work and do some stuff. And these guys rolled in, and this is 1996, and these guys were like the kings of the internet. They knew the protocols, they knew how everything worked, they knew how it all plugged together, they knew secure from not secure, things like that. And I was just super impressed with them, and I was like, that's what I want to focus on. That's what I want to do. And the thing in the back of my mind was that when I came out of college in the early 90s, there was a recession on, the Cold War had ended. So there was this, this peace dividend, and all of these people got flushed out of the defense industry. So there are lots of very experienced engineers out there that you were competing for jobs with and things like that. So it was a rough time back then. And I also wasn't the world's greatest student. So that certainly didn't help. And, I saw cybersecurity as just, it was something that people are always going to need. And kind of the flippant way that I talk about it now is that, cybersecurity is like plumbing. Everybody always needs it. It's never going away. And, the pipes are always leaking. So it's a great field to go into, because I figured it was pretty recession proof, which turned out to be the case in 2001 and 2008. And even more recently, the cybersecurity industry has been on the rise for really 25 plus years that I've been involved with it. But it's a great field. It's really interesting. It's always on the move. There's always new stuff. It's not a solvable problem, but there are really fascinating approaches to problem solving that you can apply to it. There's constant curveballs. So yeah, it's it's a fascinating field.
Yeah, that's definitely for sure. And you have a lot there that that I want to dive into. Um, recently, like you talk about, there's always like curveballs and learning curves with cybersecurity and everything. Recently I had to go through a cloud WAF POC, and I didn't realize deploying a WAF in a week is is extraordinarily difficult, just to get it in front of the app that you want to test.
Yeah.
And that's a learning curve, right? Like you're not going to know that unless you do it, or you have someone on the team that's done it before. It's like, oh no, you need this amount of time. Um, it's I mean, it's a whole other beast, right? Like you could spend your entire career doing only WAFs. You could spend your whole career doing only network detection and threat detection, whatever it might be, right? That's what drew me to it as well. The never-ending flow of information that you could dive into. When you were working for the Defense Department, or agency, whatever, um, did you were you in a situation where they were requiring you to like create your own solutions for problems? The reason why I say that, right, is because the industry is kind of built around go buy another solution, right? Go buy some other solution to fix this problem. And recently in my career, I met someone that had literally just gotten out of the Navy's like cyber warfare division. And he was talking about like we were literally discussing buying a CSPM and what CSPM works and everything like that. And his idea was to just build it himself. And
Yeah.
I'm over here, that just like blew me away. I'm like, what are you talking about, man? We're like, I'm not building that thing, and like, you shouldn't be building that thing. Like, why are we doing this, And, diving into his experience a little bit, he's like, well, they give you no budget and they give you a stack of papers that has problems in it. And they say, figure it out, like there's nothing else. They give you a terminal and like, that's it, Was that a similar experience for you, or was there a bit more hands-on trying to do the solution route? Maybe that didn't work, right? That's my thought process with it.
Yeah, they typically came in with their own. So it was a mix of using commercial stuff and their own tools. Back in those days, I was pretty young. I was in my 20s, and I was very frequently just working on problems that I was given. And sometimes we were writing software. Sometimes we were setting up and configuring systems. Sometimes we were getting commercial stuff running, or sometimes we were using open source technology as well, even back then. And it really kind of depended on what problem we were trying to solve, how fast we were trying to solve it, and things like that. So I did do creative work building technology for customers that was kind of spec'd, but it was like, here's the solution we want, go build it. So I did stuff like that, but I also did stuff like, here's the componentry that we've developed, and we need to add this to it or tie these things together or whatever. So yeah, it was a bit of everything, but the funny thing about it is that, especially in the early days, you don't know any better than to do something like go write your own CSPM or go write your own intrusion detection system, because you're kind of, you haven't been exposed to the budgets of the vendor ecosystem, the budgets required of the vendor ecosystem to get things going. And you've been kind of just making things go on your own by tying things together and building glue or building original technology. And I think that so especially when we're young, we just don't know any better. The hard part of a CSPM is not building the actual engine that does CSPM. It's all the content that's required to drive it, like all the checks and what they mean, and all configuration guidance and the CVE mapping and the MITRE ATT&CK mapping and all the other stuff that you've got to do to make it an actual useful tool, which is a lot less about building the tool and a lot more about building all the knowledge infrastructure around it that makes it go. Same thing with intrusion detection systems. I mean, I was just developing Snort as kind of a fun thing to do on rainy days and weekends. And then, all these people showed up and all of a sudden this thing like snowballed overnight into this huge thing. And, but if I had known what I was getting myself into, I would have been like, this is not, how could I possibly do something like that? So, I mean, there's always kind of that. There might be a better way to do it than it's being done by the whizzes and orcas of the world. So, I wouldn't discourage anybody from trying, but maybe it's better that you don't know what you're getting yourself into because you never tried otherwise. And that's where innovation comes from.
Right. When you were creating Snort, were you... What was the problem that you were trying to resolve with creating that? And was it simpler or more difficult than what you expected starting out?
So I was trying to solve for a few problems. One, I was teaching myself coding. I wrote and still write a little bit when I write at all in C for the most part, and so. C is a deep language. It's very tricky to do right. So I was teaching myself to be a better C programmer. I was also teaching myself how to write cross-platform sniffers. So I'd written Linux-specific sniffers and SunOS-specific sniffers or Solaris specific sniffers in the past, but I wanted to write something that was cross-platform. So I was also teaching myself how to use libpcap and things like that. So there was all that, but the goal that I was going for was, wouldn't it be fun if I could monitor my home network when I'm at work for the day and see if anybody's knocking on the door? So I would leave it running. And at that point, Snort was a sniffer with a packet logger. And I would come home, it would have the Snort directory structure of here's all the IP addresses that talk to you, here's all the port numbers, and you can look at the packet dumps and see, just visually see port scanners and people trying to brute force passwords and stuff like that. So that was pretty entertaining. But after I released it open source, about a month after I started writing it, and the 25th anniversary of the first release to Snort is this December, it very quickly, like I said, it snowballed and people started asking for features and stuff like that. So it wasn't super hard to write the fundamentals of it. It didn't really get hard until I started SourceFire, and then it needed to have enterprise features. It needed to have anti-evasion technology and stuff like that. And all of a sudden I really had to start, taking it from being this very kind of simplistic packet processing pipeline with simple pattern matching to being a much more sophisticated animal. And that took a lot of doing, but I was very motivated because I was trying to make money at that point.
Yeah, that is, I mean, that's really interesting, like creating an open source project that, everyone knows, everyone knows what Snort is, what to use it for, right? That sort of thing in cybersecurity, at least. And it's really interesting. How did people find your solution or Snort? How did they find Snort back then, right? Like, it probably wasn't easy. What did you find, like potentially a forum that all the hackers trafficked, frequently, and post about it on there? Like, how did people find it?
Yeah. So back then, there were actually very few tool sites out there where kind of everybody hung out. So, if you want to talk about it in kind of modern language, we would call it a watering hole attack, right? So you find out, the site that Snort debuted on was PacketStorm. So PacketStorm.com was run by a guy named Ken Williams. I think it's still out there, but it's under, it's changed hands several times since then because it has been 25 years. So that was like the premier tool site. It wasn't just defensive tools. It was also exploits and things like that. So like when an exploit came out, very frequently you'd be able to find it on PacketStorm. So I decided, and there were a few others like Technotronic that was run by Kirby Kuhl, and there were a few other tool sites like that. But anyway, I contacted Ken Williams and I said, hey, I got this new sniffer I wrote called Snort. Would you host it? Would you put it up on the site? Sure thing. sent it in, and got a couple emails, and then I did another release, and I got a couple more, and that's kind of how it went. But Snort was kind of fascinating because it was very much a tool for its time at the time, because the only other intrusion detection technology out there were commercial ones from like Wheel Group and ISS and things like that. They cost a lot of money. So if you wanted to do the intrusion detection function, there were really no other answers at that time. There were some other contemporary open source intrusion detection systems, but Snort kind of captured the easy enough for anybody to use, but deep enough for people to get sophisticated with, especially as time marched on, and it grew in sophistication. So yeah, it was it's product market fit. It's what we would say now. Its product market fit was exceptional for its time. And it led to this product led growth kind of motion, was what we would call it now. That was really incredible. But yeah, there were a surprisingly few sites in the late 90s where kind of everybody hung out, all the tools were and stuff like that. And that's how I got started. There was no greater marketing than just putting it up on PacketStorm and Technotronic and a few other sites, and it just took off.
Wow. Yeah, you bring up a really good point. The product is a balance between anyone being able to use it and then diving as deep as they want to go. Right. That's I guess that's a problem that some products that I've seen have had recently, right? Where it's either it's not deep enough or it's not simple enough for anyone to pick it up. It's a really fine balance between that, and it always seems like the people that have been doing it for 20, 25 years are the ones that, understand that. So like, even if they step into a product, right, that is struggling in that area, they can navigate it and kind of untangle it, I guess.
Mm-hmm. Yeah, I think it's funny. So my career in computers started when I was 17, working at a retail computer store. I was a service technician, and this is in the late 80s. And the interesting thing was there's this big movement in the computer industry back then for PCs to deliver a great out-of-box experience. So this was like early attempts at low friction deployments, low friction selling, stuff like that. So when you got your consumer PC, you'd open up the box, all the cables would be labeled and stuff like that. So it was simple, and they color coded the connectors. So it'd be simple to plug this thing in and get it going, because a lot of people had trouble with that. And I think that that's always in the back of my mind. In Netography, my current company, the thing is, it's easy to get started with, but it's also very deep. Snort was kind of the same way, very simple rule language that was in there, and you could do a lot with the rules, and you could get more sophisticated, especially as we added stuff like regular expressions and things like that. But it also was an extensible engine. So if you could write C, it had all sorts of API interfaces in it where you could extend the program. You could add in your own detection logic. You could add in your own output mechanisms to talk to databases or whatever you wanted to, and things like that. So there were many levels to the system, but the most cursory level you could still be productive with almost immediately, and that was the whole goal. From out of the box and up and running in 15 minutes is what the mantra was at SourceFire. But even with Snort, I want to be able to go from tarball to running Snort instance in 5 minutes, and that was kind of the always my guiding thing in the back of my mind when I was developing the packages and things like that.
Yeah, I feel like that's a stat or a thought process that is still rare to come across, right? Of being able to download it and run it and be up and running within 5 minutes. Mm-hmm. That is not something that is seen very often, right? As someone that has led various POCs across different domains of security, like this recent POC that I did with the Cloud WAF, there was one solution that within 2 hours, right, we were up and running. It was still 2 hours, but it wasn't the 10 days that I needed for the other solutions, and that's absolutely something that matters, especially when, you talk about like a disaster recovery scenario and someone else that doesn't know the tool, someone that didn't buy it or take part in the POC even has to run it. They have to know how to do it and they have to be able to figure it out. I feel like personally, all of that has to be taken into account when you're purchasing the right technology.
Yeah.
It's an interesting problem. So I'm fascinated by your current company, and I want to dive into it. So tell me a bit more about what you're doing now. What's the company called? All that stuff.
Sure. So the company called Netography. We're a network defense platform. So this is something new under the sun. It's not NDR. It's not SIM. It's not XDR. It's its own thing. And the fundamental problem that we're trying to solve is that, especially since the end of the pandemic, networks have scattered. So everybody went home in March of 2020, and they were told, "Hey, just get your job done. We'll be back in 2 weeks." And that turned into 6 weeks, and that turned into 6 months, and people just got their jobs done, and they scattered their enterprise networks to the four winds, basically. So all of a sudden, we have this huge cadre of work from home people. We've got all this cloud infrastructure that was just kind of thrown up as needed by whoever needed it, wherever they needed it, for whatever they needed it for. And now we're kind of trying to get our hands around it as an IT industry. And it's really difficult to just answer fundamental questions of what have I got? What is it doing? What's happening to it? How's it changing? And being able to do so systemically across this multi-cloud plus on-prem world that most enterprises are in today. And the funny thing is I kind of saw this problem coming a long, long time ago. And it's also compounded by encryption and now zero trust, which is basically based on this foundation of let's encrypt everything and then we'll give permissive access to whatever you need based on your credentials and stuff like that. Well, all that stuff works great until it doesn't. And, and we've merely been blinding all the ways that we used to keep tabs on things for the last, call it 5 to 8 years. So what Netography is doing is we have a cloud platform. So it is a cloud native platform that can take data in from your infrastructure and tell you what's going on, what you've got, what it's doing, what's happening to it. But we're doing it in a way where you don't have to deploy a bunch of technology to make it work. We don't have appliances. We don't have agents. And we work the same across any cloud environment that you've got. Well, the 5 big ones anyway. So IBM and Oracle, in case you're wondering what the other 2 are, plus GCP, AWS, and Azure, and on-prem, all under one roof. So we have one UI, we have one language that describes good and bad and what we're looking for, and things like that. So it enables us to do compromise detection, threat hunting. We do governance with it because the way this thing is built, we can see configuration drift happening in real time. We can see when things are not behaving as they should. You can just do straight up discovery and mapping with it. And it's also surprisingly good at picking up DDoS attacks and things like that. So it's a really different approach from what's come before. Obviously Snort was a deep packet inspection system. And I started becoming concerned with kind of the future of DPI back in probably 2008, 2009, when all of a sudden network encryption started to turn into more and more of a thing. And here we are, 15 years later. And now network encryption is blinding DPI very systemically. It's hard to get a DPI sensor where you need it, especially in the cloud, because the cloud's not friendly to doing deep packet inspection. Nobody likes appliances anymore, and it's a terrible model. It has huge lifecycle management, curation costs associated with it. Not to mention, what it's telling you is, hey, I saw a bunch of things which could be attacks. Please figure out which ones are attacks. So what we've done in Netography is really change the game and the equation to give you something that's super low friction, right? So this is all the way back to the early days of Snort and my experience as a technician in the early PC industry of from out of box to up and running as quickly as possible. Time to install matters, being frictionless matters. So and letting you see things instantly about your environment. Like you don't even have to configure our stuff. As soon as you plug in the data sources, it will start telling you stuff about your network that are very hard to see otherwise, without you even have to configure it. And then once you start configuring it, it just gets richer and richer with what it can tell you. It's got a language in it, so you can extend it. So, the easy stuff is easy, the hard stuff is possible. It's all API driven, so you can plug it into your infrastructure and extend it and things like that. So this is a new way of doing network security that is built on really leveraging your existing infrastructure. So we take flow data out of your on-prem infrastructure and flow logs out of your cloud infrastructure as a real-time data source for the activities that are occurring in the environment. But we also pull context out of your environments as well. So we can pull context out of your EDR, like CrowdStrike. We can pull context out of your VPCs in the cloud. I get it from Axionis or Wiz, or working on extending and integrating all across the board. So you can look at your network traffic and activities that are occurring, not just in terms of show me all my database servers, show me all my executives and what they're connecting to, but you can also do things like say, show me all of my traffic that is occurring to devices with CVSS scores above 7.5 that are responding to the public internet. It's really super powerful way of understanding your network environment and being able to look for attacks and compromises, as well as just provide you with kind of fundamental governance capabilities, which once again are hard to do with scan and report tools like vulnerability management or even CSPM tools.
Wow, there's a significant amount there, right? And I feel like, okay, so I have two major questions. How do you build a product that is working great for the cloud as well as on-prem, right? Like I feel like that is designing for two completely separate things, and that's a gap that's hard to bridge. So how did you accomplish doing that?
Well, I'm just the CEO, so I didn't actually do it. But the guys who did do it, they saw the same problems that I did. If you have a bifurcated security platform where I treat on-prem differently than I treat the cloud. I mean, the cloud, the joke is the cloud is somebody else's computer, but really the cloud is somebody else's Linux computer, and you don't really own the network. But there is a network, and you need to understand how it's being utilized, and you can really see what's going on by observing it properly. And then you've got the on-prem world. If I have two different technology stacks for looking at both of those things differently, you're going to have gaps between them, gaps in capabilities, gaps in visibility, gaps in understanding. You're probably going to have different teams running the tools. Like you've got just this ever-expanding pile of problems because you're treating them as different things. Your enterprise network is a composite of all of its components, and you need to treat it that way. And that's what this platform is really designed to do. Treat your network as a composite of all its parts instead of this part is different than that part is different than that part. Well, if you're going to do that, you have to understand, okay, what are the fundamental data types that I can pull out of here that will show me the information that I need so that I can treat these as different aspects of the same thing. Well, it's flow data. It's there's other data types out there like DNS or HTTP logs potentially, or whatever that aren't in the product right now, but obviously we're aware of, as well as the context that you need to have. You've got all these platforms out there that know all sorts of things about kind of their area, where it's CSPM knows about the configuration and vulnerability state of cloud workloads. Or a vulnerability management system does the same thing about what's happening on-prem, or like an Axionis, which is which is more of a CMDB sort of platform, or an EDR like a CrowdStrike, which has very granular data about the systems that it's installed on, but it isn't installed on everything in every enterprise. So, like being able to weave that picture together and then show the activities that are occurring on it is extremely powerful. And it takes a little bit of imagination, but this problem's been staring us in the face as an industry for at least a decade. And Netography is the first company that's come along that's really synthesizing this picture based on all these data sources, and then giving you one way to analyze it and instrument it and treat it as your enterprise network, not as that's cloud A, that's cloud B, and this is my legacy on-prem stuff.
I would assume a solution like this does a really good job of detecting kind of rogue cloud accounts, right? If you have a developer that determines, right, that they want to use their company card to start an account with GCP or something like that when you're predominantly in AWS, that would probably be something that would be pretty easy for you to detect, right?
Yep, absolutely.
Yeah, I have a pain point with that because I started at a company a couple of years ago, and they told me, oh yeah, 100% AWS. There's nothing anywhere else. We have O365, but that's it. Okay, and then I slowly started to find out through the grapevine of people, mistakenly saying it that we're in Azure, and then randomly, we're also in GCP. We're using this other thing in GCP.
Yep.
It's like, guys, this is a problem. Like, security didn't know this.
Well, and it's not just that. This is like, and you're never going to see it, like, unless somebody tells you about it. Like the old way that we would do things with DPI systems is probably not going to find it either, because deep packet inspection systems are primarily focused on what? They're focused on finding threats that are active in the network environment, and they're looking north-south almost exclusively, and they're only looking for attacks. So they're not even going to characterize the kind of the connectosphere, I guess I'll just coin a word right now, the connected, the connected biome of your actual enterprise network, because they have no ability to observe it. It's outside the scope of their application. Whereas an approach like what we're doing in Netography will show you north, south, east, west, doesn't really matter. We can instrument any part of your network. And oh, by the way, the other cool thing about it is that as soon as you become aware that, we got stuff in GCP, you can shake information about what deployment you've got in GCP out of the people who are doing it. And you can deploy, because we are cloud-based, you can deploy now, like right now. You don't have to deploy an appliance. You don't have to get a workload up and running or anything like that. You guys turn on Flow over there and give me your VPC context. We'll import it into Netography and we'll see what's going on. Boom. And then you've got all of a sudden visibility into it, and you can start seeing what's actually there, and you can start instrumenting how you actually want to protect it and govern it.
Yeah, I feel like that's a huge pain point, especially with the pandemic, and everyone working from home. There's no longer that oversight that used to be present, and so then you can have situation where employees, are starting to spin up and use other technologies and other platforms to accomplish their job that the company didn't even know about and whatnot. One of the areas that I would imagine would be a difficult area to master, especially with a product like this, is alert fatigue. And avoiding it and making sure that you're providing, the end user only what they need to make the proper decision in an environment, and showing them what they should be paying attention to. How do you address that within your solution? Because I would imagine, right, having all of this data, and doing all of the logic and the matrices right behind it, I would assume that is a difficult challenge to go through.
Yes. Okay. So now you're gonna get some orthodoxy here. So let's talk about threat detection and compromise detection, because this is the difference by degree. So I obviously am one of the people who's primarily responsible for the threat detection game as it's been done for the last 25 years. Like, I established a fairly iconic piece of software that is kind of the one of the foundational elements of event generation for detecting security incidents in an environment. Here's the problem with the approach, and this is my analysis of how we're doing with this approach after 25 years of doing it. The problem is that Snort can detect hundreds of thousands of things now, and there's tons and tons and tons of rules for it. And the issue is that if you don't configure your rule set appropriately, you're going to get a lot of noise. Even if you do configure your rule set properly, you're still going to get a lot of noise. The vast majority of things that it detects, because we don't have the granularity to do a host by host configuration of what Snort should detect on a device by device basis. We're just going to look generally for the things we think could be problems. We're going to get an event load out of that, and then we're going to sift through that event load. We're going to contextualize each and every event that's in there for the stuff that I care about. And then of the stuff that I care about, I'm going to try to figure out which of those events that I actually care about were actually compromises. Am I going to look for anything beyond compromises? In most enterprises, you're not. You're just going to say, I've turned 10,000 events into 10 events of interest. I'm going to look at those 10 events of interest. Oh, none of them actually affected anything today. Guess I don't care. And tomorrow, none. And the day after that, none. And then the day after that, oh, there's one. Oh, I did get compromised. Woohoo. Let's kick off our IR playbook. And we are going to image that machine, reformat it, and get it back in service. And we're going to take that image and run it through our forensics and our IR process and figure out what's going on. And that's what people do. So what's the flaw with that? Well, I did all of this stuff. I curated all these rules. I got these Snort sensors up and running. I got them tuned and configured and performant, working at the rate that I want them to. And I swapped out, every 3 to 5 years, I swapped out the hardware platform that they're on because I have to, because either the vendor that I got it from is forcing me to because it's end of life, or, I need a faster machine because I'm pumping more bandwidth now or whatever. So I did all that stuff so I could deal with tens of thousands of false positives. No matter, like at SourceFire, we invented whole new technologies to get rid of false positives. We were good at it. We give you 95% data reduction, not too, without too much effort, but you're still dealing with 5% of 10,000 or 100,000, trying to figure out which one of these are the ones that I care about. And, and at the end of the day, the outcome that you're actually going for is, I would like to know when I've actually been compromised so I can kick off my IR playbook and get back to business, right? So we do that. We have been doing that for 25 years. Or what if I just said, hey, actually, nobody cares about threat detection. Everybody cares about compromise detection. That's the outcome that you actually want. Well, what we built in Netography is actually more of a compromise detector than a threat detector. Because what we've come to understand now that we have a lot more gray hair and we're no longer, time is actually a factor now, is that what if I only tell you about the stuff that was compromised by being able to essentially suss that out by looking at the activities and behaviors of the devices in the environment, establishing, because I'm a metadata-driven platform that knows a lot of context about the environment, I can establish where are my trust boundaries, what are my functional, behavioral, operational envelopes that I operate within. And then I can essentially observe the entire network and all of it, not just the north-south traffic, but the east-west traffic, the stuff in the cloud, everything, and look for stuff essentially going off the rails and tell you with a very high degree of accuracy, hey, this thing has been compromised. That's probably the bet that we're making. This is the thesis at Netography, is that's probably what people actually want. The outcome that people want is compromise detection so they can kick off their IR playbook. I've been reading blog post after blog post. Kevin Mandia just talked about it. Essentially, it's all kind of the subtext of all these things. Coinbase just did a 3-parter on how they're making detection and response scale. And all of it was, we take this raw event load, we contextualize it and marry up context with it. So when we figure out what the actual compromise is, we have the contextual information associated with the event that was the compromise, so we can respond more quickly, so we can kick off our IR playbook. You see it over and over again. That's the outcome that people actually want from all this analytics, this massive analytics infrastructure that we've deployed for really 30 years. Finally, people are getting to the point where it's like, hey, actually, I don't care about every SQL Slammer attack that is still, out there, the background radiation of the internet. I only care about the stuff that I could actually be affected by. And because when I generate an event, I know this is a very long drawn out explanation, when I generate an event and it goes into my event processing pipeline, it ends up in front of either my level 1 guy in the SOC or my very small team, it's going to be hours at least before that person sees that event. So the difference between detecting the attack when it happened and detecting that this machine has gone off the rails and is in fact compromised from a temporal standpoint, again, doesn't really matter. You're going to get the same outcome at the operator level. So that's what we're going after with this approach is, hey, let's just tell them about compromises. Let's not worry about defining every attack, because we're not doing layer 7 inspection anyway. I can't do layer 7 inspection the way that we're doing things. Now, there might be stuff that I can do down the road, looking at things like DNS and HTTP and stuff like that might give us deeper capabilities to find more fine-grained attacks. But fundamentally, what I really want to tell you about is when things have gone, obviously, off the rails. And that's something that is doable with the approach that we've taken here. And what it frees you up from is all this curation and lifecycle management, signature management, false positive rejection, all this crap that we've been doing since I was a kid. If we do this right, and we are definitely seeing a lot of success with our approach so far, that's where we think we're going to make a big difference.
Yeah, that is it's a totally different way of thinking about this problem and how it should be addressed. I worked with, I think it was a XDR or something like that, right? Whatever coin term they had, and it was the most inundating tool I've ever experienced before.
Yeah.
Especially when we deployed it, and we have 5,000 alerts in there, and my manager's like, oh, well, each one needs to be justified for. Like, we're a financial institution, we have to have a justification behind all of it. And I'm sitting here like, how am I going to make justifications for 5,000 alerts? Like, that's 5,000 alerts today. This isn't even 5,000 over a year. And that was like the most frustrating thing I've ever experienced, because it's like, now I'm spending 100% of my time on this, and I'm not even able to do like good enough quality of work on it that I'm comfortable with, because like, if I have to put my name out there saying, oh yeah, this is a benign alert, this doesn't matter, this is why it's false positive, whatever it is, right? Mm-hmm. I don't even have the time to do the research myself to go into it, even in the data that they claim that they have within their platform. It was just such a headache.
Yeah, it's insanity. I mean, it's literally like the fact that, and there's whole sectors of the security industry that are all about, oh, got alert fatigue, we can help. And nobody's just saying, why do we have all these alerts? We can't look at the, despite the fact that we can do high fidelity detections, we can't actually make a high fidelity determination that you should care. And you have to have either a human being look at that, or maybe you can have an AI look at it, or, do some contextualization so you can reject all the stuff that can't possibly be a problem. But, beyond that, you just have to ask yourself the question. And, the maybe not funny thing is that all the way back to the early days of Snort, I used to tell people, don't run all the rules. For God's sakes, do not run all the rules. What you need to do is you need to run the rules for things you could possibly be affected by, and then write rules for stuff that should never happen in your environment. And that's how you should run Snort. And everybody looked at me and they're like, oh, that sounds great, Marty. And nobody did it. Because it's kind of a pain in the butt. And you have to stay on top of it and understand the things that should never happen. And it gets harder and harder as the network gets bigger and bigger. Well, we've essentially turned the problem on its head and said, look how scattered these networks are. I coined an acronym for what modern networks are. I call them DEED environments. They're dispersed, ephemeral, encrypted, and diverse. This is what represents modern network environments. And Snort's still out there, still doing a great job. If you want to defend the crown jewels of Snort, that's probably a good idea. But like, for broad capability across your entire DEED environment, your entire dispersed, ephemeral, encrypted, diverse, multi-cloud plus on-prem network with a work-from-home workforce, you're nuts if you even try. So I'm a software developer, software engineer guy, but I'm also, I did 5.5 years as chief architect at Cisco and for security and things like that. Like, coming up with an architecture that'll work across all this stuff is like something that I had to do, that I do now. And that the team at Netography, the actual co-founders of the company, came to the same conclusions that I did without talking to me, which is why I'm working here. Because we were like, we have the same idea, let's go. And they actually built it. I just, did a whiteboard exercise. This is the only way, from what I understand, and I've been doing this for a while, this is the only way to attack this problem. scalably across, take all comers and things like that. This is the only way, if you're going to do it, this is the only way that you can do it. We'll get, more sophisticated and we'll add in more data services as time goes on and things like that. But you can't do it the old way. The smart way isn't going to get you where you want to go anymore. And, if you start looking at the outcomes that people are actually trying to get to and things like that, you start to say, hey, wait a second, we should really rethink the problem that we're trying to solve and how we solve it.
Yeah, that's a really good point. It's I feel like that's it's a problem that, obviously it needs to be solved, but it can only be solved by the people that, have done it for that long. You have to have the experience with it. You have to be able to say, oh, this is a bad workflow here. Like, this doesn't make sense for, 99% of the organizations out there. And finding that new way to work, especially with the cloud and how dispersed, networks are, it sounds like that is, honestly, it's probably like the only path forward that we have. And, I'm sure in 20 years, right, we'll look back and be like, oh, we have this other, brand new thing that allows us to prioritize things differently, right? But that's 20, 25, 30 years away,
Mm-hmm.
If we're talking about the modern day, cloud and how it works, especially with on-prem connections and whatnot, that is the only way to go forward with it.
Yeah, architecturally, in a lot of ways, the way that this thing works is it's modeled on the way that EDR works. So EDRs, if you understand how EDRs really do their thing, they collect metadata about what's occurring on a device, they ship it up to a cloud backend, they do their magic on the cloud backend, then they send back determinations to the agents that are on the devices. We're doing something kind of conceptually similar where we're taking the data coming out of the infrastructure itself with no agents deployed or anything like that, no sensors, no agents, no hardware, and bringing it all to a cloud backend, doing analysis, and then we can respond out via our APIs through whatever your local native infrastructure is to be able to respond to attacks or whatever else that you care to respond to. And the cool thing about it is that much like an intrusion detection and prevention engine, our system works in real time. It is not a store and query system like a Splunk or an XDR or, a lot of the technologies, almost all the technologies that are out there. We, I think, almost uniquely do what we do in real time. We can look back, we have look back capabilities and stuff like that. But we're actually, as data arrives, we analyze it, run it through our processes and our models and things like that. If we see something happening, we can actually respond as it's happening too, which is, once again, architecturally, like, I'm a person who thinks about things for a long time before I execute on them. In fact, I thought about this for 10 years before somebody else executed on it, and then invited me to come be the CEO, which was great. Sometimes there really is only one kind of, given the technology of the day, one way to go about it. And in my opinion, this is it.
Yeah, being able to alert, while an attack is going on or while a compromise is going on, that's really critical, right? Like, it's probably a stupid statement saying that it's critical because it's obvious, but it's not obvious of how many solutions out there, that even claim that they can do this and, fall short. And there's many companies that have been compromised for, significant amounts of time. I think the average compromise isn't detected for like 6 months or something like that.
Mm-hmm.
And that's with all of the modern day technology that we have. And, this is the same for large companies and small companies, like they have 300 people on their security team and then companies with, 3 people on their security team, they're experiencing the same thing. So it sounds like this solution is really like leveling the playing field in a way, right? Because you don't need to be a network expert to dive into this thing. At least it doesn't sound like it. It works across all the platforms. And, it allows you that if you're curious, you can dive into, a certain request or whatever it might be more and find out the details about it. That's a really, interesting solution that you have there.
Thanks. Yeah. It's, it's, we believe, obviously, or we wouldn't be doing this. We believe it's a game changer. But it is, time is a factor, obviously, in every attack. And the interesting thing, so there are, to your point, there are vanishingly few technologies that are able to actually detect and respond in real time. So EDR is one, IPS and NGFW are another, and there's not really a whole lot else out there. So the very, very sharp end of the spear technologies like those are kind of it. I guess WAF is too, for example, to get back to the pain. but the next level down. And the thing to understand is that EDRs run in block mode all the time. It's very natural. But like most IPS detection logic does not run in block mode. We saw kind of 80-20, even at the SourceFire days, when we were the premier intrusion prevention platform out there. Only about 20% of our customers actually ran our stuff in. The fascinating thing about it is that the next step is essentially getting into an eventing pipeline where an analyst looks at it and decides if it's compromised or not, and then does something about it. But in between that is the ability to recognize something going off the rails in real time and signal out to your infrastructure to do something about it. So it isn't quite at the point of attack like you'd have with an EDR or an NGFW, but it's as soon as compromise is recognized, we can respond, which is pretty cool. And we also have the ability to respond to things like governance issues. So, for example, if I see configuration drift happen, say you've got like Wiz, and Wiz figures out, hey, Dev and Prod are talking to each other in your cloud app. You need to fix that. And then you go do it. And then, push comes out of staging, and all of a sudden Dev and Prod are talking to each other. A Wiz-style CSPM isn't really going to see that till the next scan cycle. We see it as it happens. We see it in real time, and we can even signal back to Wiz and say, hey, by the way, this just happened, so you might want to take a look at it and make a determination, or we can signal to their, the operations team and say, hey, we just saw this, and this is contrary to your configuration directives.
Man, well, I feel like we could talk for another 2 hours easily,
Yeah.
but unfortunately, due to time, we have to cut it a little short, or I guess not short, but we have to, delay our conversation, right?
Mm-hmm.
But Martin, before I let you go, why don't you tell my audience, where they can find you, where they can find your company, and all that good information if they wanted to, find out more about your solution. I'll put all the links in the description of this episode, of course.
Yeah, absolutely. Netography.com. That's where I am these days. And that's, if you take a look at the website, start digging into it, you'll see what we're up to and what we're useful for. If you want to get a demo, we're always happy to demo for people. And, there's a lot that you can look at on the site. And if you're looking at the site and you're looking at the screenshots, asking yourself, wow, does it really look that good? It does look that good. Our GUI is awesome. And it's also composable, so you can actually make your own dashboards and things like that. So it's an extremely powerful system. But Netography.com, please check it out.
Awesome. Well, thanks everyone. I hope you enjoyed this episode.